All right, so we're going to look at ellipses today, and that's section 8.2 in your book. I found this really neat demonstration that tells you a little bit about how an ellipse works. So we talked about the foci of the ellipse. So the foci are the points that basically are creating the ellipse. And if you notice what happens, that you have this rotation from the foci, the sum of the distances, so the red and the blue line added together, are always 6. And it just so happens that 6 is the length of that major axis. If we look at that, that's the value of A. So as I increase this, the major axis, so as I increase the value of A, then the red and the blue line will always equal that value. So that gives you a really good idea of how the foci are used, and we talked a little bit about it in class in terms of what the foci are, another way for them. So the foci, or the ellipse, we already talked about, are the points, the set of points that are formed by that distance between the foci and any point on the graph, and that is a constant distance all the way through there. The major axis is always the larger axis, and the minor is always the shorter axis. The major axis is always going to be represented by the value of A, and the minor axis is always going to be represented by the value of B, and then the foci are always going to be the value of C. So if we look at our formula sheet for a second, you'll notice that for ellipses, we have the x squared minus h squared over a squared, and then over b squared. And here it looks the same except for the a and the b are switched. So A always has to be bigger than B because it's your major axis. So we're looking for that value that's bigger to decide which one we're going to be doing. So since the major axis is on is on X, then that means that this has to be a horizontal ellipse. So our ellipse is going to be in this direction. Okay? Since our major axis is under Y for this one, then our ellipse is going to be vertical for this problem. So that's one of the things to keep in mind. So as we look at these examples that I gave you, you'll notice that on the first one, our center is 0, 0. So the H and the K is 0 and 0. Since 16 is bigger than 4, then that means A has to be the 16. So A squared is 16, therefore A is equal to 4, and B is equal to 2. So our ellipse is going to be a horizontal ellipse because the larger value is under X. On the next one, again, our A value is going to be 8, B value is going to be 25, our center is going to be 0, 0. So we can use that information. Oh, and also since 64 is under Y, then that means it's going to be a vertical ellipse. Okay? So going back to our formula sheet, we can use that information to figure out the value of C. So C squared is equal to A squared minus B squared. So it's sort of like Pythagorean theorem, but a little bit different. So I could use this information to find the value of C. So C squared would equal 16 minus 4, which is 12. So C equals the square root of 12, which is 2 square roots of 3. So we could use that information to graph our points, and we'll talk about how to graph it in a second. For this one, C squared would be 64 minus 25, which is the square root of 39. So C equals the square root of 39 on that one. Going down to E for a second, our center for this one is 2, 1, and A is going to equal 3, B is going to equal 2, and C is going to equal the square root of 5. And again, you're doing not the Pythagorean theorem, you're doing A squared minus B squared. The center is 4. Oh, let me go back one more second. And so since 9 is under X, that means it's going to be a horizontal ellipse. On this one, A is going to be 5, B is going to be 3, and therefore C is going to be 25 minus 9, which is 16, so it's going to be 4. The center is 4, negative 2. The bigger value is under Y, so it's going to be a vertical ellipse. This last one here is understood to be over 1, so therefore A is equal to 4, B is equal to 1, and C is going to be square root of 15. The center is negative 2, 3. The bigger value is under X, so that means it's going to be a horizontal ellipse. Okay, so ellipses, if you notice our formulas back here, ellipses always have to be set equal to 1, right? So on these two examples that we have here, our values not equal to 1. So we have to do a little bit of math. So on this one, we're going to divide everything by 100. So 25 with 100 in the denominator is going to be x squared over 4. And this one's going to be y squared over 25 is equal to 1. So now A is 5, B is 2, center is 0, 0, and C would be 21, square root of 21. Okay. On this problem, I have to rearrange it a little bit, so I have to move my 35 and move the 5y. And then when I divide by 35, I get this as my standard form. So the center is 0, 0. A, this is going to look a little strange. A would equal square root of 7. B would equal square root of 5. And C would equal square root of 2. So they're going to look a little strange. Their numbers are on the graph, but they do look a little bit different than what we have. So then if I want to graph these graphs, what I'm going to do is plot my centers first. So on the first one, I'm going to plot the 0, 0. And then I want to plot A, which is my major axis. And since it's horizontal, I'm going to put 4 points to the right, 4 points to the left. My minor axis is B, so I'm going to go up 2. I'm going to go down 2. And then my foci is C, which is 2 square roots of 3, which is about 3 point something. So my foci are going to be right here and right here. And so there's my ellipse. And my foci are inside the ellipse, and you could use those to plot the points. So let's do a couple more. So the second one, our centers at 0, 0 again. Our A value is 8 and our B value is 5, but it's a vertical ellipse, so we're going to go up 8. And then we're going to go down 8. Our minor axis is 5. So we're going to go 5 to the left and 5 to the right. And then C is square root of 39, which is a little bit more than 6. So we're going to go up about 6. So we're about right here. And then we're down about right here. And so here is our ellipse. As best I can draw it. It's not a very good ellipse. So there's our ellipse that's horizontal, a vertical this time. So let's do one of these that has a center that's not at the origin. So this one has a center at, well, let's do this one. This one has a center at 4, negative 2. Okay, so we're doing F. So the center's at 4, negative 2. So we're going to plot our center point first. And then we already decided that since the bigger number's under Y, this is going to be a vertical ellipse. So we're going to plot our A value by going up 5 from the center. So 1, 2, 3, 4, 5. And then we're going to go down 5. And then we're going to plot our B value by going to the right 3. and to the left 3. And then our foci are going to go up 4 from here. So there's our foci, and our other foci is here. So here's our ellipse. Now if I asked you for the ordered pair, I can now get these ordered pairs without having to use the formulas. So my ordered pair for my vertices are 1, -2, and then 1, 2, 3, 4, 1, 2, 3, so 4, 3, and then 4, -7, and then 7, -2. So those are our vertices, and our foci for this problem would be at 4, 2, and 4, -6. Okay, so you can use the graph to find your foci and vertices, or you can use your formula. It's a little bit easier to use the graph. Alright, so here's another example. This time you're given the foci and you're given the vertices and you're asked to find the standard form. So what you have to remember is that the foci and the vertices are on the, in this case, on the major axis. The foci are always on the major axis. So my foci is at -2 and +2, and the vertices are at -3 and +3. So I know that C is equal to 2, and I know that A is equal to 3, because A is always the major axis. And the foci are always on the major axis. So I can use that information in my Pythagorean theorem or my formula to find the value of B, and B is equal to the square root of 5. So I have everything I need to put into my standard form. So x squared over 9, y squared over 5 equals 1. So here's another one. So foci are always on the major axis. So if I graph this, my foci are at 0, 3 and 0, -3. So that means that it's got to be a vertical ellipse. So the vertices are at 0, 4 and -4. So this has to be A and this has to be C. So then doing Pythagorean theorem, I would have 9 equals 16 minus b squared. So b squared equals 7. So b equals square root of 7. Okay, so I have everything I need. So it would be x squared over 7 plus y squared over 16 equals 1. I know that this has to be A, because y, it's a vertical axis, and this has to be my B, and then again the C is used for the foci. So let's do an example of putting an equation in standard form. So here we have an example like that. So we started off like we did with the circles, and we rearranged the problem and put it with the x's and the y's together and my number on the opposite side. Now I want to complete the square, but I have to have a 1, so I'm going to factor out the 9, and I'm left with x squared minus 4x. And when I complete the square on this, half of 4 squared equals 4. And now I'm going to factor out the 25, and I got y squared plus 2y, and then I complete the square and I get 1. So here's the biggest trick. I have 164 on the side. Normally I would say I have to add the 4 and the 1 to the other side also, but it's not just 4, it's 36. And it's not just 1, it's 25. So I have to add 25 and 36 to this side, so I get 225. So then I factor this, it's a perfect square trinomial, and I factor this, perfect square trinomial, and then I divide